On Saturday, 27th of February 2010, at 3:34 am, an earthquake magnitude of 8.8 struck the central south region of Chile, affecting an area with a population of 8 million people. An earthquake is a sudden violent shaking of the ground as a result of movements within the Earth's crust. The consequences of earthquakes include economic, sociological, environmental impacts, as well as structural, geotechnical, and transport infrastructure problems. The problems we will focus on are structure failures as well as crowd management and evacuation plans. The Higgins Tower failed during Chile's 2010 earthquake. The building experienced dramatic failures in its upper levels that were likely a result of stiffness discontinuities and vertical irregularities in the structure. The failure of tailing dams is another consequence of earthquakes. A tailing dam is a structure built for the purposes of storing mine waste and water. The direct issue resulting from this is the distance the tailings travel due to the liquefaction of the soil, hitting other structures such as bridges, roads and houses, and damaging them. During an earthquake, a loss of lives and homes will cause trauma within Chile, and demand for the medical services will exceed the capacity. An evacuation plan is essential to buildings and structures. It ensures safe exit of the building in less than 8 minutes, hence minimizing the costs. An evacuation plan includes having trained officers who know the evacuation drill, good signage towards safe zones, and speakers to broadcast the instructions throughout the complex. Evacuation routes must be clear without any obstruction. The places where an evacuation plan is crucial are structures with high capacity. An example of this is the National Stadium in Chile, which reached an all-time maximum of approximately 95,000 people. In 2000, the capacity of the stadium has been reduced significantly to reach a reasonably safer and quicker evacuation. The central field can hold 14,000 people, and surrounding area can hold 250,000 people. The stadium can be divided into two zones, where the bottom tier would evacuate to the field and the higher tier would evacuate to the surrounding fields. Why do structures fail in the event of an earthquake? The soil fails, the foundation fails, a building joint fails, and so the building fails. So what can we do to improve the structure? Two methods will be discussed in this video. The first one is base isolation. The concept involves floating a building above its foundation on a system of bearings, springs, or padded cylinders. Bearings attach the building and foundation via steel plates, and then, when an earthquake hits, allow the foundation to move without moving the structure above it. The second one is cross-bracing. Cross-bracing is a system utilized to reinforce building structures in which diagonal supports intersect. The X-brace consists of two slender members in the form of an X. They are often simply or rigidly attached at their end connections to the framework, and are pinned or rigidly connected at their point of intersection. The system is free to deflect in the plane or out of the plane of the framework.